Okay, so in the last video we looked at the new PNR calculation of using the TSE and the fuel flows and the SGRs to get a PNR in miles. So now we're going to actually work that out. So the first thing we're going to do is figure out how to get our TSE. So the way that they might word this in the exam is something like find the distance and time to the two-engine PNR IFR flight given the following information. So we know it's an IFR flight. I always like to put this heading at the top of my page so I remember when I'm looking back at my reserves or my reserve requirements what type of flight I'm doing. So IFR flight. We have 1,828 pounds of fuel on board. We have a TAS for two engine of 140 at a fuel flow of 600 pounds per hour. Now 600 pounds per hour is just the example given. Don't get confused with working out the mid-zone weight. This is purely for this example of 600 pounds per hour. In an exam question, they may give you a different number, or you may actually have to calculate your fuel flow first. A 15 knot headwind component on the way out at 4,000 feet, and a 15 knot tailwind component at 3,000 feet. And an instrument approach is required at the departure point. So remember, we are creating a new flight plan from the departure point to the point of no return, turning around and going back to the departure point. So if there is an IFR approach at the departure point, we need to include that in our removal of fuel when working out the TSE. So the way that we work out the TSE is we basically work backwards from our flight plan. So remember, our flight plan starts with the climb, then it goes to the cruise, and it goes to the alternate. We're going to start with our known fuel on board, which is 1,828 pounds, and we're going to start removing items from the bottom up. So first thing, start/taxi, 40 pounds. Our fixed reserve for IFR, if you can remember, is a 30-minute reserve, and at 600 pounds per hour, that's going to be 300 pounds. Our instrument approach is just as normal, 50 pounds, which gives us a total of 1,438. So go 1,828 minus 40 minus 300 minus 50 equals 1,438. Okay, we have to come to this number first before we remove the variable reserve. So now we need to figure out, is it going to be 10 minutes or is it going to be 10%? So again, you can work out what 10% is times 0.1 is going to be 143.8, or 10 minutes at 600 pounds per hour, which would be 100 pounds. So that's going to be less than our 10%. So in order to remove the 10% from this number, and remember it's not 10% of this, oh yeah, I actually cocked that up. It would be 143 1438 divided by 1.1 minus 1438. Yeah, so 130.7 as opposed to the 143 or whatever I got. So it's actually 10% of our legs in our climb, not 10% of 1438. I did that a little bit backwards, but the 10% is still the higher. So we have a variable of 10%. Now the way that we remove that is the opposite of the way that we add it. So we want 1438 divided by 1.1. And that is going to give us 1307. So I normally write 1.1. The 10% is in the 0.1. If you wanted to remove 20%, you would do 1.2 and so on. So 1307. So that's our fuel minus our 10%. Now we still need to minus our 2-minute climb, because remember we were climbing up to 4,000 feet, 1 minute per 2,000 feet, so we're going to remove 2 minutes of climb, and that is 20 pounds at 600 pounds per hour. Now remember that if you get a different fuel flow, this number is going to be different. So minus 20 is 1287. 1287. This number here is our TSE. So now we have all the information on the page to write out our PNR. So remember, our PNR calculation is now TSE divided by fuel flow out divided by ground speed out plus fuel flow home divided by ground speed home. And we're going to put that into our calculator exactly this way. And in fact, I'm going to write out the numbers. So 1287 divided by our fuel flow out is 600 pounds. 600 divided by our ground speed out. So out is a 15 knot headwind with a TAS of 140. So that's going to be 125. 125 plus 600 divided by our ground speed home of 155. 155. Let's put that into God. Let's throw the calculator first and then let's put it into it. So 1287 divided by 600 divided by 125, close bracket, plus open bracket, 600 divided by 155, two close brackets, equals 148.4, 148.4, or 148 nautical miles. The point of no return is 148 nautical miles from the departure point. Once we go beyond this number, we can no longer return back to home with either out going into our reserves or potentially running out of fuel. So this is a very important calculation to be able to complete. So this is a 2-engine PNR from the departure point. The next thing we'll look at is a OEI PNR. So at what point can you no longer return if you had an engine failure and had to return back to your departure point at OEI speeds and at a different altitude, which might have a different or will have a different ground speed and different fuel burn. And that's where being able to plug in different numbers in here is useful, because remember that these are SGRs and they're the flipped SGRs. Cool. Hope that makes sense.